What we're going to do here is work on a basic program to give ourselves an introduction to the Kotlin programming language, as well as have a refresher of some important object-oriented development concepts that we're going to see as we move into app development on Android. So this will be a very basic console program. This will have nothing to do with mobile apps. It's just a way for us to sort of get our feet wet without worrying about the complications of Android. So I'm going to create a new project in IDEA, and I'm going to call this project First National Bank. And the idea here is that I'm going to create a program that captures some of the basics of a bank, specifically things like bank accounts and some of the data and operations that are usually involved with those things. So First National Bank is the name of my project. Of course, I'm just on the new project. I'm not selecting any of the generators. The language is Kotlin. I don't care much about the build system, but IntelliJ is what I will select. I'll need a JDK, so OpenJDK 18 is perfectly fine. You could download a more recent version, or if you ever run into issues, you could use an older version. Either works. I will leave add sample code selected just so that I have a project that's generated and gives me sort of a good project structure that we can see here on the left, so I can figure out kind of where things go. So this is my basic project. Right now, I have one file, main.kt, that's generated. In my project explorer here, you can see that this file exists under source, main, Kotlin, main.kt. We don't have to worry too much about the project structure. This is just the way the build system has organized the files in our project, so that when we compile, which we can do by clicking on this right arrow, this play button, this run button, it will compile all of our code to a bytecode if it's running on the virtual machine, and execute it. So let's take a look at what we have here. And I'm going to draw comparisons between Kotlin and a language you might be more familiar with, Java, to sort of demonstrate how Kotlin does things differently and how Kotlin does some things that are the same. So the first thing is, when you're working on a Java program, you'll note that there's usually one class that you start with, and inside of that class there's a function called, or a method called public static void main, that has an array of string arguments. Kotlin has something similar, except it does away with the need for that main class, a bit of under the hood information that this actually will be turned into a class, but we don't have to worry about that when we're writing our code. So instead, it simply has what it calls a function. So we no longer use the term methods in Kotlin, just functions. And to be clear, a method is in fact a function. It's just a function that is associated with a class definition or associated with objects. Kotlin, however, treats a function as a first class construct. So it can exist even if it's not associated with a class. So the syntax here is fun, which is the prefix for all functions, main, and then it also takes a set of arguments. And as you can see, whereas in Java, the type precedes the name of the argument, in Kotlin, it's reversed. The syntax is the name of the argument, the variable, if you will, colon, followed by the type. And this is how it's used, or this is how we declare properties or variables or values, as we're going to see in a moment, throughout the language. Here we see a message being printed, hello world. So system out print line from Java is just replaced with print line. And here we see another statement being printed. And what we notice here is that within the quotation marks, we have this expression. And this expression, when you actually run the program, will be evaluated. And whatever the value is, the resulting value, will be displayed as a part of the string. So compare this to Java, where if you had an expression that you wanted to evaluate and print the result or join the result with a string, you would have to do string concatenation. Kotlin does away with the need for string concatenation. You can simply place the expression that you would like to evaluate inside of the $ curly bracket syntax, and whatever you place in there will be evaluated. So this is the basics for it, and what we'll do is simply have a heading for our program. So first, National Bank, and I'll run this program just to see what it looks like. And at the bottom of the screen, we'll get a little console window popping up, and we should see my first National Bank message being printed to the screen. So here it is. All right. Next, we want to actually start building the artifacts that are necessary for our bank. And we're going to keep this very simple. We know that the main purpose of a bank, generally speaking, is to manage money, and money is managed through the use of bank accounts. So it seems like a good enough place to start. If we want to create a banking program, let's start by creating the artifacts necessary to manage the money that the bank generally manages. So I'm going to right click on Kotlin, the Kotlin folder in my Project Explorer. I'm going to select New Kotlin class or file. And then I'm going to type in the name for my class. In this case, it will be bank account. And this will create a new class file for me, or a new class inside a file. Here we see the file called bankaccount.kt for Kotlin. And the syntax here looks very similar to Java. And then from here, what we want to do is specify first the properties of this class. What is the information that a bank account needs to store? Of course, we could come up with a lot of different things, but I'm going to keep it simple, and I'm going to come up with, I'm just going to add, let's say 2 or 3 of the main things that we know every bank account has, generally speaking. First, we will have an account number. So for account number, I am going to declare that this is a val. Now, when declaring a property in Kotlin, you have the choice of either creating a value or a variable. A value, denoted with the VAL keyword, is a value that cannot change once assigned. As such, I'm using this val for account number on the assumption that once you give a bank account an account number, that number cannot change. So val account number, then I follow it with the type. In this case, my account number is going to be a string. And the reason I'm using a string versus any of the number types such as integer or long is that despite its name, account number, the reality is in most instances, account numbers and unique identifiers of that sort tend to actually be strings. Even if you find that the string contains numeric characters. The rule of thumb that you can use to determine whether or not what you have is a number or a string is whether or not you are going to perform arithmetic operations on that value. So in the case of an account number where I might be randomly generating a sequence of characters or the values may be alphanumeric, what I would have is a string. Now, it may be possible that for a bank, account numbers are incremented each time a new account is created. And in that scenario, you may say, well, I'm performing a numerical or an arithmetic operation. And, that's an argument that could go either way. But fundamentally, I think the real question is, again, is this something I need to perform operations on? And if it's not, or the operations you need to perform are very simple, like incrementing, then what you probably have is a string. So I'm going to make my account number a string. And at this point, you might think, well, I'm finished. Certainly, if I was in Java, I would be finished at this point with the declaration of my property. But in Kotlin, I'm not finished. And the reason I'm not finished is that I've not provided enough information for Kotlin to be satisfied that this program will run. In fact, it won't run. And the reason is that I've specified that account number is a string, but I've not given it a value. I've not said how account number is going to get how it's going to be initialized. And that is something that Kotlin insists that I do, or at the very least, be explicit about the fact that it's not happening. The reason Kotlin does this, among other things, is that Kotlin tries to be type safe and null safe. It wants to ensure that it has null safety. So it doesn't just set a value or a variable to null if you don't provide a value, because it turns out that in languages that allow for nulls to be assigned willy-nilly, you oftentimes end up with null pointer exceptions without realizing it throughout your code. So Kotlin is trying to introduce null safety by forcing you to either initialize with a value or be explicit about the fact that this particular variable can and should be null. So for argument's sake, if I wanted this account number to be null, I would need to tell Kotlin that this is not a string. The type for account number is not a string. Rather, the type is a nullable string. So I'd have to put a question mark. Essentially, for every type you have in Kotlin, you can have a nullable version of that type by placing the question mark after the type name. So this is now telling Kotlin, account number can be null, but that's still not good enough. Even after saying this can be null, I have to give it a null. I have to do all of this before Kotlin will let me move on to something else. It is trying its darndest to make sure that I do not have a null pointer exception later on in my code. So I don't actually want account number to be nullable. And I'm going to come back later and fix this, but for now, just to get rid of that red underline, I'm going to leave this while I move on to the other properties, and then I'll come back to it. So account number is my first property. I could also have, while I'm at it, let's say the account holder name. In this scenario, I might say that maybe the account holder name can change. There's nothing fixed about a person's name, and it could in fact be updated. So in that case, I'm going to make this a var instead of a val. So I'll call this name, and I will say this is also a string. And for now, I'll say it can be null until I change this again. And the last thing I'm going to have here is the balance. Of course, how much money is in the account. This will also be a var because certainly we can appreciate that the balance in a bank account can change. And for the type, I'm going to use double, but I want to make a note here that when you're creating quote unquote real world programs, it's important that you don't actually use double when representing money values, or at the very least, you need to be acutely aware of some of the problems that can arise. Specifically, you have to appreciate that when a floating point number is being represented in a computer's memory, it is actually stored as an approximation, not necessarily the exact value. And this has to do with the fact that decimal places can go on to infinity, but unfortunately, a computer's memory is finite. So it essentially gets truncated at some point or rounded off. Because of this, you can actually run into issues when you try to compare two double or two floating point values that are intuitively are supposed to be the same thing. But because of how they're stored in memory, again, stored as approximations, the numbers are different by a very small number, by a very small difference. So this can cause issues with trying to do operations, mathematical operations on floating points. So the proper way, if you are building a program that you want to be resilient and make sure that you're not running into these possible errors, is to the proper way to represent money is to have a money or a currency type that can represent, in the case of say US dollars, can represent the dollars portion as an integer and the cent portion as a separate integer. And then by doing that, you can now introduce all type of functions to perform whatever operations you'd like, subtracting one money object from another money object or adding them together, etc., etc. So if you wanted to be thorough, that's the way you do it. But for our simple example, I'm going to use double with the caveat that I just laid out. Like in the real world, we would have to be very careful about this. All right, so in this scenario, I am creating a double, and you'll notice that the double here starts with an uppercase D. This is also different from Java, where Java says that everything in Java is an object, which would imply that it has a class that defines it. However, primitives are the exception. Kotlin, however, does not have that exception. In Kotlin, everything is in fact an object, and that means it has a class that defines it, including our primitive values. So doubles, integers, booleans, all of these actually have a class in the framework that represents it. And when you're declaring a value of that type, you use the class name for the type, which is the uppercase initial letter. So similar situation here, I could make this a null. I have that option, again, because this is in fact an object. I want to note here that Kotlin does in fact have the ability to delay initializing a variable using the keyword late in it. So for example, I could say that this string, this name, instead of saying it's going to be null, I could say, all right, this particular variable is going to get an initializing value later on. And you can tell Kotlin that this is the case by simply using the late init keyword. So this is basically putting the onus on you, the developer, to make sure that you initialize this value later on. But at least in Kotlin's perspective, because we are doing this explicitly versus by accident, I imagine the assumption is it is less likely that we would introduce an error, and we would in fact make sure that this value is initialized because we were explicit about its initialization. And in fact, an attempt to access the property, if it hasn't been initialized, throws a different exception. It does not throw a null pointer exception. It throws a not initialized exception. So this is something that we have the ability to do. And I mentioned this because I want to point out that even though we said that primitives in Kotlin are in fact objects and represented by classes, Kotlin is still aware that they are primitives, and there are some constraints. For example, you cannot do a late init for a primitive value. So this won't work. So this is just a note. Even if you decide to use late init, you can't actually use it for primitives. That being said, we're not going to use late init, nor are we going to use nulls for any of these properties. Instead, we're going to initialize these properties with values that will be passed in to a bank account object every time one is initialized. And we're going to pass those values in by way of a constructor. So we're going to give our bank account class a constructor. In Java, a constructor is defined via a special syntax for a method that shares the name of the class. In Kotlin, you can specify what's called a primary constructor by simply placing parentheses after the class name. So this is the primary constructor. In Java, you have what's called the default constructor. The idea is the same. The usage is a little different, and of course the syntax is different, but they try to accomplish the same thing. So in this scenario, if I want to now have values passed in to initialize all of these properties, then I can just request them in the constructor. Namely, I can say that when you are initializing or creating a bank account object, you need to pass in an account number. And I'm using the underscore here just to differentiate between the argument that's going to be passed into the constructor and the property, and you're going to see why in a moment. So account number. is going to be a string. Name is going to also be a string. And balance is going to be a double. Now that I have my account number, my name, and my string arguments being passed, my name and my balance arguments being passed in, what I will do is use these values to initialize these properties. Now, I can just go ahead and do something like this as a way to initialize. However, Kotlin actually makes this a little less verbose. And that is because Kotlin has the ability, or essentially does not require you to explicitly state the type of a newly created property if Kotlin can determine the type itself. Specifically, in a situation like this, where the argument being passed in from the constructor has a known type, Kotlin essentially says, well, if the value has a type the value that you're using to initialize the property has a type, then if you don't state your type explicitly, I will simply use the type of the argument being used to initialize me as my type. So the type from underscore account number becomes the type for val account number for our property. And I can do the same thing for everything else. So var name is equal to underscore name, and var balance is equal to underscore balance. So all of my properties are now initialized, and they have the types that were associated with the arguments used to initialize them. So at this point, what I have is a bank account class that has 3 properties. And these properties are accessible to outside classes, for instance, main, or outside entities. So main can access all of the properties of a bank account object if we create one, because by default, all of these properties are public. This is another distinction from Java that may not have been obvious or clear just because of how we tend to build very basic Java applications. But in Kotlin, we have these things called visibility modifiers. In Java, those things were called access modifiers. And the modifiers essentially specify how entities external to the class can access the values inside of an object or inside of the class as we're defining them. So for instance, can I write code in main? If I had an object of type bank account, would I be able to access a property defined here? In Java, the access modifiers were public, private, protected, and package private, where public is the most accessible and private is the least. And in Kotlin, the 4 are, I believe, public, private, protected, and internal, where public is the most accessible and private is the least. So the default in Java is package private. The default in Kotlin is public. So all of these are public. And what's also important and interesting to note is that when a value, a property like this is made public, it automatically has accessors and mutators associated with it, meaning an external class, an external entity, can access the properties and either check them, read them, or change them. Sometimes this is what you want, sometimes it's not what you want. And what we're going to have is basically a mix for bank account. We're going to see that for some things, it's perfectly fine to allow them to access it. For other things, it's not fine. So let's first just create a bank account object in our program. And then we'll try to access it and see what we can do. So first, I'm going to create a bank account. This bank account, I could explicitly specify the type. But as we mentioned before, if Kotlin can figure out the type, you don't need to be explicit about it. So what I'm going to do is just create the object and assign it to the value. And Kotlin will, from that, determine that the type of the object should be the type of the value. So here I will basically say that I'm creating a bank account. Another difference between Kotlin and Java, when you want to create a new object in Kotlin, you do not have a new keyword. Instead, you just invoke the constructor. So for us, we want to create a bank account, and our bank account is going to be provided with an account number, a name for the account holder, and a balance, the starting balance. So the account number is a string, so it'll be ABC123. The account holder name will be Sarah Morgan. And the balance, let's say the balance is going to be $450. Now, recall that the type for balance is double. And let us say that I want to enter 450. What I've entered here is an integer. And if you've done development in Java, you'll know that if you try to store an integer in a variable of type double, or basically you try to pass an integer value in any context where a double is required, Java has no problem with that. Essentially, it does what's called a type promotion, where it determines that as long as changing the type of the value to the type that is required does not cause loss of information, then it's perfectly fine, and it will automatically cast it, if you will. The reverse is not true. You must explicitly cast, say if you were moving from a double to an integer, because that can cause loss of precision and loss of information. Kotlin, however, does not do automatic promotion, and you must either convert the type or make sure that what you're passing in is of the necessary type, of the required type. So by putting 450.0 or 2 zeros, since it's money, it looks nicer to us. This is going to now be assigned to the balance property. So now that this is done, we can test this by trying to print, let's say, the account holder name. And I can evaluate the account holder name inside of the string. I do not need to concatenate. So it's simply bank account dot name. And if everything worked, we should be able to see account holder name, Sarah Morgan. Next, we can do the balance. And we see Sarah Morgan, 450. Great. Now, let us say I wanted to change the balance. So I might take my bank account and I'll say the balance is equal to 1,000. That's something I could do. It may not make a whole lot of sense, but it's something I could do. So I'll do that. And I can see that it starts out at 450, then it becomes 1,000. Now, the reason I say this doesn't make any sense is because of something that we know about banks, which is you usually don't just set the balance of a bank account. Instead, the balance of a bank account is changed by applying an operation. There are lots of different operations, but the two most common that you would be aware of is you're able to make a deposit to a bank account and you're able to make a withdrawal from a bank account. So these are two operations that we can perform on a bank account that would change the balance. So we wouldn't just set it to be 1,000. What we may do is deposit 550 to get to 1,000. So it would be something like balance is equal to balance bank account dot balance plus, well, if we say plus 1,000, then we have 1,450. So that's one way Of course, this is very clumsy. This is actually not what how a deposit you would imagine would be performed. What's more is this is problematic because because I have direct access to the balance, I can do crazy things. Like I can add $1 million without any checks. Is that a million? That looks like the right amount of zeros, which sounds great until I mistakenly maybe placed it at a negative 1 million. Again, all valid with my bank account, because right now my bank account has no controls. Everything in my bank account class is public and accessible to any entity that wants to access or manipulate it. So the first thing we need to do here to fix this problem is to essentially focus on one of the first principles of OOP, object-oriented programming, and that is encapsulation. The idea of encapsulation is that elements inside, things that make up the inner workings of a class, should be hidden away, tucked away from the outside world, and the only things that should be visible or accessible are essentially interfaces that we control, functions that we expose that allow the outside world to interact with our object, which will allow us to put controls and checks and balances in place. So that's what we're going to do here. We're going to prevent the arbitrary manipulation of our balance, and we are instead going to ensure, via encapsulation, that a balance can only be manipulated in controlled ways. So what we're going to do is start to make our properties private. Now, it turns out that just because of this feature of Kotlin, where a setter and getter are automatically created for us, we don't need to go crazy with our with setting properties to private. It turns out that for some things, like account number, which is a val, which means it cannot be changed once it's initialized, and the name, which we want to change, we may or may not have certain rules about how you change this, but if we did have rules, then we would make it private and then create functions to control it. But for the simple, just to keep things simple, let's say we want to leave name as public. But balance, we want to make private. We want to make sure that you can't just reach in and manipulate balance. And once we've made it private, if we look at our main class, you'll see that every attempt to access balance is now throwing an error. There's a problem. It cannot access it. So that's exactly what we want. And now what we want to do is create a set of functions that will allow the outside world to manipulate balance. So first thing I'll do is I'll create a getter. That is a function that you can invoke if you want to see what the balance is. So for me, that'll be fun for function get balance. This is a function that is going to return something. In Kotlin, that syntax is : and then the type that is being returned, the type of the value. The balance is a double, therefore we're returning a double. Then I'll have my curly brackets. And now I need to use the return keyword along with the value that I'm returning. And it's that simple for a simple getter. I don't need to do any calculations or anything else. I just return balance. Now in my main, in the instances where I want to read the balance, which is line 7 and line 11, instead of just accessing balance directly, I'll call get balance. And similarly here, get balance. I'll make this a comment just so we can run or execute the program, and we can see that at this point our program works. I see 450 both times. So my get balance function is working exactly as I intended. Now I want to create some mutator methods or setter methods. And the mutation here will not be simply accepting a value and making that the balance. Rather, we're going to define the type of operations that you can perform on a bank account. Specifically, I'm going to have a function to deposit a certain amount of money. This function will not return anything. So there is no colon on type. And what I'll do here is essentially do a check. So if you are depositing, I want to make sure that you can't deposit a negative value. They may have other checks, but this is what I want to do. So if amount is greater than 0, so you can't deposit a negative value, nor can you deposit 0. If amount is greater than 0, then balance is going to be increased by amount. Similarly, if I'm going to create another one, withdrawal, you will also try to withdraw a certain amount, and this function will also not return anything. Well, we'll just call this withdraw, not withdrawal. So if you try to withdraw, I'm going to do a check. This time I'm going to check two things. I'm going to check to make sure that A, amount is greater than 0. So you're trying to withdraw a positive value. And the amount you're withdrawing is less than or equal to the balance. If that is the case, then we can reduce balance by amount. So those are my mutator methods. That's how I can access or manipulate or change the balance in some ways that have controls or checks that I put in place. So if I go over to my main, at this point, if I wanted to do an update to my balance, I could make a deposit of, say, $650, which would then change my initial deposit of $450 to a new value of, well, I should have put $550, but sure, $1,100. So that's my deposit. And of course, I could do a withdrawal of $200. And if our code works, I should, after 1100, I should see 900. What's more is if I try to do a withdrawal that is more than my balance at this point, if I try to withdraw $1,000, even though I only have a balance of 900, then that withdrawal attempt should be ignored, and we should still see 900 as my balance. So there we have it. The basics of encapsulation. For our bank account, we are able to define a set of properties that are accessible to the outside world and in some cases hidden away. And then we provide a set of functions. And of course, all of this is with Kotlin's own peculiar syntax, own unique syntax. A set of functions that allow the outside world, specifically our main class, to manipulate the state of a bank account object through a series of calls to depositing or withdraw, and then check the state with a call to get balance. Next up, we are going to look at inheritance.